are going to be introducing you to two of the most important pieces that you will be introduced to in a science class. The first is going to be the safety rules that should be put in place in any science classroom. Number one, I will not, absolutely no horseplaying or goofing off.
Not at all.
Not. Alright, safety rule number two,
I will not eat or drink or chew gum during labs.
not, absolutely no eating, drinking, or chewing gum during labs. This is Hydro Flask, no. Visco girls, be gone.
Don't even touch it. Don't even bring it into the classroom.
Alright, safety rule number three is use caution when hitting any chemicals, heat, hot plates, Bunsen burners, any kinds of chemicals. Alright, for example, here we have three unknown substances. We have a clear one, a purple one, and a white powder. Alrighty, let's see what happens when we mix them. I don't know. Next, safety rule number four.
Safety gear.
Always wear your safety gear. Whether it's gloves or goggles, wear them! Always!
You will burn your eyeballs off.
Safety rule number five. Report all accidents immediately. Report them! Every single one. Report! And that is all the safety rules that you will need to know. The next thing we're talking about today are atoms. We're going to be talking about the subatomic particles that make up atoms, all the parts of an atom, and we're going to draw some atoms. We're going to talk about the variations of atoms and isotopes. Alright, the first thing that we're going to talk about with atoms is going to be all the subatomic particles that makes up an atom. So we have a proton, a neutron, and an electron.
Oh boy.
Look at that, those are the pieces of an atom. Proton. Proton has what kind of charge? A positive charge. A neutron has what kind of charge? No charge. Electron, take a guess. Any guess? No one? Alrighty, it has a negative charge. Alrighty, what's next? Alright, proton has mass. Its mass is 1 AMU. What's the mass of a neutron, Emily Steinwell?
1 AMU.
Oh man, what's the mass of an electron?
Nothing.
No mass for an electron. Alrighty. Anybody know where you get the mass? It's called the mass number. It's on the periodic table. You got a little box there with the big letters and little numbers. Here's your things you're going to see on the periodic table up there in that top left corner. You're going to see that's the atomic number. Alright, right underneath of this, you're going to be able to see that this is a phosphorus. That's what this little P stands for, is a phosphorus. You're going to see that right under here. Alrighty, and then right underneath that is going to be your mass number. It's going to have about 1, 2, 3 whole numbers. After that, it's going to be a bunch of little decimal points. Alrighty, that's your mass number, everybody. This is just a cute little explanation of what you're going to see on a periodic table. The number of protons here is going to be about this atomic number. Twice the atomic number. It's going to be about the mass number. Next is going to be the parts of an atom. So we're going to take this cute little thing called a proton and this cute little thing called a neutron. Both of these things are going right up here to this nucleus. See that? That's a proton, that's a neutron. You've got the nucleus. It, like I said, it contains protons and neutrons. It is a very small portion of the size. So let's say that your atom is this big for some reason. Your nucleus is going to be about right there. Very, very, very small portion of the size. The next part of it is going to be the electron cloud. So that's pretty much what you're going to see here. This is the electron cloud. Tiny nucleus, giant electron cloud. 2 electrons in that ring. We got 1, 2, 3, 4, 5, 6, 7, 8 in that next ring. 1, 2, 3, 4, 5, 6, 7, 8 in that next ring. And on this outside one, which we're going to call our valence ring, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 in that one. Doesn't matter, even if you didn't have this outside ring, this one with 8 would be your valence electron shell. Each of your valence electrons is going to be the very outside of your atom, kind of like its, shell, hence valence electron shell. Alright, we're going to draw a carbon atom for you today. Like you said, P is proton, N is neutron, E is electron. So we're going to start with carbon. So on that little square I just erased, it'll have a big C, but it'll have a little 6. The number down here is going to be approximately 12. A regular carbon atom is going to have 1, 2, 3, 4, 5, 6 protons. And then it's going to have 1, 2, 3, 4, 5, 6 neutrons.
A regular carbon.
The normal one that you're going to assume is it every time. This is your first electron ring. You got 1, 2 on that inside one. Then you got 4 more to make 6. So you got 1, 2, 3, 4. And as you can see, there's room for 4 more on this outside one. Next is the varieties of atoms. What are those varieties of atoms, Emily Steinmel?
This is our regular neutral atom. So then we have ions.
What is an ion, Emily Steinmel?
Ions are atoms with a charge.
We have 2 kinds of ions. We have anion, or we have cation. So anions,
they have a negative charge.
Negative charge, which means that there are more electrons than protons. Electrons greater than protons. Cations are going to be your opposite. I'm going to have more protons than electrons.
Because
protons,
it's a positive charge.
Protons greater than electrons. And if you're a cat person, you can remember, cats give you a positive vibe. Ions are created when electrons are either added or removed to form a full valence shell. Let's take our cute little carbon atom here. So, to make a full valence shell, like I said earlier, we're missing 4. So if we were to add 1, 2, 3, 4, this is now an anion because there are more electrons than protons. Right now for electrons, this has 10, which is a lot greater than the 6 protons. This here is an ionic atom. It is an ion. The second type of variation of an atom is going to be an isotope. Isotope is going to mean that there are more neutrons than protons. Neutrons greater than protons. Alright, so let's take our carbon atom here. But then, it just happened to spawn with 2 extra neutrons. This is a very common isotope of carbon. A carbon-14 isotope, which would be labeled like this, C14. You see that? Carbon-14. And naturally occurring stable isotopes do actually exist. Carbon-14 is one of them. 2 ways to name those. So we either have, like I showed here, C14, otherwise known as carbon-14. And then there is one more way to do it. So like for carbon here, the mass number of this one is going to be 14. The atomic number for this is 6, and the symbol is a C. So this is the same thing as that. That's the other way to name an isotope. All right, coming back to our first thing, safety rules. We're going to talk about how these things could apply in the real world. All right. Let's say you are a construction worker.
Ooh,
you're going to be wearing probably some goggles, maybe more like glasses. You're going to be wearing a hard hat. You're going to be taking care of all kinds of scary stuff, alrighty? As a construction worker, you may not be working with chemicals.
But you're not scientists, but you could be building a house.
How is this dangerous, Emily Steinmel?
Extremely dangerous. There's all sorts of big pieces. There's a door. Doors are big and heavy. Doors are bigger than me.
Always lock your doors.
If there's windows, there's glass.
How do construction workers protect themselves?
Well, they wear their safety gear. This little hat
Oh yeah.
keeps from breaking your brain out. Okay? What if this roof fell down on your head? You would have a less chance of killing yourself with the hat on.
Very valuable information.
Now, when you're building a house, the pieces you get to build the house aren't all the right size. So, you gotta use a little saw. That's my saw. And when they're cutting wood, stuff goes everywhere. This little guy's mouth, sawdust, not good for you. So if this guy had a little bottle of water, if the sawdust was to get into his water, he would consume it. He could die, okay? You gotta move it far away, and you can't have it anywhere near your sawdust because you'll consume it and you could die. So when you're also building a house, you can't be running around all over the place.
This is true. No horseplay, you're goofing off!
Because the pieces to the house are big. If you're running around, making a fool of yourself,
You're gonna fall off.
yeah. What if you're all the way up here, working in the attic, and you're running around? You could fall, you could hurt yourself, but like say you're still on the ground, you could still be hurt on the ground. You could run into the door could fall on you.
All true.
No running around.
All right, if you have an accident, let's say that you're using this cute little saw here. What if you got your finger in? Shoot, no more finger. What happened? I don't know. Go report it to your construction crew leader. Report all accidents immediately. And then we've got the structure of an atom. So an atom is approximately the same setup as like a town, So you've got your nucleus, but instead of neutrons and protons, you got buildings.
In this town is your protons and your neutrons.
Your protons are going to be your people that live in regular houses. They're just, there having a good time. So these people are like the protons because they do affect the mass of the city. They go to the city, which is our nucleus, and they go to work. So they affect that. However, these elderly people, for the most part, are going to stay at home. They're not really going to go into our nucleus downtown and go to work. However, protons do. So the electrons are going to be like the farmhouses. So we've got big farmhouses out here. Got one here. We got a big farm out here. We got all kinds of farms. These are like the electrons. They're outside of everything else. Electron shells are like the outside, and they like not really protect, but they're like there. And the farms kind of do the same thing for the city. They also determine the city limits. Now, in a lot of towns, farms like this are not considered inside of city limits. However, if you have a farm outside of your city, you still say, oh, I live in Hudson, even if you don't live in the city limits of Hudson. So the valence shell determines the atomic radius and diameter of this atom. So there's kind of your example in the real world of what an atom could be like if it was a real world situation.
Thanks for coming to our TED Talk.
Stop shaking. Every single, these are bothering me. They got them.
I don't know what I'm supposed to do.
Number 1, have markers that work.
Nah!
What is safety rule number 2? Use caution! Oh God.
Don't feed them.
We're recording, get out! Put down your chemicals! Alright.
Is there a marker in here?
Close the door! Safety rule number 713! Lock the door!
Lock it!
Interfere with your experiment! This is so cool.
Ooh!
Look at this magic. Gorgeous! How do you spell immediately? That is not it.
I don't know if that's right. Woo!
Lock all doors!
Woo!
Got my safety gear on! Oh! This is why we wear safety gear.
That's coming!
Oh! Don't forget your safety goggles. Nucleus. That's not a nucleus.
Neutrons are the nucleus!
Let's try that again.
I'm really glad that wasn't the open marker. I like these shoes.
You see that occurring? We have 2. I just threw sugar everywhere.
Wood isn't clean. You can't eat that.
Bottled water.